Colonizing the Mars is the biggest project in mankind may require humanity to enhance our space technologies. This will give rise to a new era of civilization, the planetary civilization. Mars is an for sure source of inspiration and primary destination for science fiction stories on interplanetary travel. The possibility of life on Mars is a subject of huge interest in astrobiology due to its proximity and similarities to Earth. To date, no proof have been found of past or present life on Mars. Cumulative evidence shows that during the ancient Noachian time period, the surface environment of Mars had liquid water and may have been habitable for microorganisms. The hypothetical colonization of Mars has received interest from public space agencies and private corporations, and has received extensive treatment in science fiction writing, film, and art. Reasons for colonizing Mars may include pure curiosity, the potential for humans to provide more in-depth observational research than unmanned rovers, economic interest in its resources, and the possibilities that the settlement of other planets could decrease the likelihood of human extinction. Powerful propulsion system to get us there quicker. Astronauts bound for Mars will travel about 140 million miles in deep space. Advancement in propulsion capabilities are key to reaching our destination as quick and safe as possible. Inflatable heat shields to land astronauts on other planets. The largest rover we have landed on Mars is about the size of car, and sending humans to Mars will require a much bigger spacecraft. New technologies will allow heavier spacecraft to enter the Martian atmosphere, approach the surface, and land close to where astronauts want to explore. High-tech Martian spacesuit. Spacesuits are essential custom spacecraft for astronauts. NASA's latest spacesuit is so high-tech, its modular design is engineered to be involved for use anywhere in space. Martian home and lab on wheels. To reduce the number of items needed to land on surface, NASA will combine the first Martian home and the vehicle into single rover complete with breathable air. Uninterrupted power supply. Like we use electricity to charge our devices on Earth, astronauts will need a reliable power supply to explore Mars. The system will need to be lightweight and capable of running regardless of its location or weather on the red planet. Laser communication to send more information home. Human missions to Mars may use lasers to stay in touch with Earth. A laser communication system at Mars could send large amount of real-time information and data, including high-definition images and video feeds. Establish a culture. Assuming their sperm or eggs have not been zapped by cosmic radiation on the way to Mars, then sooner or later, a certain percentage of settlers are going to want to have kids. This is, after all, the only way of popularizing the colony over generations. For it to be successful, the population needs to be large enough to avoid inbreeding over subsequent generations. Facing the radiation dangers of interplanetary travel. On Earth, our planet's atmosphere and magnetic field protects us from hazardous space radiation. Even astronauts on the International Space Station are flying within the Earth's magnetic field, shielded from the most of the radiation. CERN is a strong source of radiation, a gigantic fusion reactor constantly sending out charged protons and other atomic particles and occasionally erupting like a volcano. throwing out intense and dangerous bursts of radiation. Galactic cosmic radiation is dangerous in itself, but when it is smashed into spacecraft walls, the shower of secondary particles can make the astronauts' living quarter even more hazardous than being outside. Leaving Earth's protection, however, means exposing astronauts to the severe galactic and solar radiation. Even staying on Mars is dangerous. The red planet has almost no protective magnetic field and the surface is bathed in the high levels of radiation. Understanding how genetic material is modified through the protracted radiation exposure of a long interplanetary journey is important because it could raise the risk of cancer and cardiovascular diseases later in life. Soon, in one way or another, humanity may finally know whether our neighboring planet ever hosted life and whether there's a future for our species on another world. Only time will tell.